Okay, we are 3 minutes past, so let's get going. So, thank you everyone for joining. So, uh, uh, like I need to drop at the bottom of the hour. So, but Hannes and Deb are here, so they will keep this going. So let's get going. Hannes, thank you for taking notes. So the note well applies here. This governs everything that we do at the IETF. If you're not familiar with this, please make sure you get familiar with this. It is important. So we had two interims already, and this is the third one, updating security BCP. And remember that we still have one more interim next week. And so that's our agenda for today, talking about updating security BCP. Any questions, comments? Okay, good. So let's get going. I think you should be, Adonis, you should be able to share and then drive slides. Let me do this actually. And I'll pass the slide control to you. Let me see if you can you control that slide now? And if you want to go on mute.
Let's see. Okay, I have a next and back button, right? Okay. Yeah, cool.
Yeah. Okay.
All right. Cool.
Go for it.
Thanks, Rabbit. Okay, cool. So today's we are talking about this updating security BCP. As you can see from our author list, we have Tim and Pedram. Initially, this work was started by them, and then they are specifically talking about the audience injection attacks. And then you see Kaishin and Adonis' phone. Me, myself, is Adonis. We are more specifically focusing on the part regarding the OAuth use to facilitate account linking in all sort of different AI platforms and those hottest systems. So this is my first time talking in IETF. So I would use this chance to give a little introduction to myself. I work at Samsung as an engineering director. And I hope that, I could use the language. I myself is an engineer, doing security work and also engineering tasks, also sometimes hack, systems. And also, doing this researching work, with, the Chinese University of Hong Kong. So I hope that, I can use the language, and I hope that, in this meeting, we can see where we go. We hope that, we will have more aligned expectations and see, if we can get this sufficient attention from the community, and hopefully, move towards, having this adopted as the working group draft. So next is that, a little bit about the background. I think Kaishun, is, do you guys see my mouse or cursor? Or I don't have any pointers?
I don't see a mouse. I don't know about the pointers.
Is there a way that I can do that?
I don't think there's a way you can do a pointer.
Oh, okay. Okay, so it will be a little bit challenging. So let me try. Let me give this a good try. So, this is just a little bit about, all this history, how, the team has involved with IETF. It started, I guess, largely with a lot of efforts, sponsoring the students, to go to the Iceland workshop. They presented this audience injection attacks over that conference. And then also, back then we call this mix-up reload attack. In the Iceland conference, they spoke with the original authors, as far as I understand, and then they have very in-depth discussions back then. And there is a number of follow-ups meetings, after that. And the consensus roughly back then was that, let's start a new draft. We are not going to overload our RFC 9700 and make it forever lasting there without publishing. So 9700 was published, and we probably want to start a new doc And then we are proposing to use this new topic, security BCP, updating security BCP. We are perfectly open to the title of this new RFC or this new draft. And then lastly, it was discussed during July 25th last meeting, and then we have some updates over there. And then in that meeting, the outcome was that we want to have a more in-depth meeting, and then there we are. Okay, so OAuth attacks. There are so many. Today, we want to focus, specifically on some hottest deployments. Everyone is trying to use OAuth to build connections, connecting tools, integrations, to some platform or service or OAuth client, or sometimes we call them AI agent service or chatbot, to orchestrate these sort of tools. We define this OAuth connection context with having this, roughly this tuple. Like, this is basically how we do things. Like, I personally architect one such systems at Samsung. And we have Samsung Bixby, we have smart homes, we have also in the Samsung account, I'm personally responsible for the Samsung Bixby system. And then, from the engineering perspective, it is very easy to, and as we observe from all other systems that, we have no influence outside Samsung, we see that, it's very, very true that, you, as an engineer, you will think of having a tool, and then this tool will have some sort of OAuth provider. This OAuth provider is to incorporate, perhaps your authorization server endpoints and client ID and client secrets more typically. Okay, and then you sort of have this tool to connect this OAuth provider. This OAuth provider, is responsible as a configuration to drive a client to negotiate eventually an access token. And this access token will be used by this tool as in, an encapsulation of, different functions, we could say, and which eventually hit some API, with the access token that we negotiate using the OAuth provider configuration. Okay, and then, to even incorporate, this latest hottest, deployment, we see that there is OAuth as a service from the market where, we are even outsourcing this OAuth client, not from the platform or the service, but with a separate entity. Some names include RK, and then maybe AWS, it has also has a service that is performing this OAuth as a service. So OAuth provider lives in this OAuth as a service, and then, they would help with negotiating an access token eventually for you. Tools you can still build by your own, and then at the end of the day, you have an access token, you drive your tool to help with maybe AI orchestration. Okay, and of course, there are so many varieties. No matter what, maybe it's just a workflow system, Microsoft Power Automate, Amazon Alexa, Google Home, and then maybe the entire class of voice assistants that you can name off, Alexa, Google, Samsung Bixby, Alibaba, Baidu, and there was another one, there are 6 platforms, that all based on all this same OAuth design. And it happens that, basically all the names that you see here, and then including this OAuth as a service all the way, we found them vulnerable. Okay, so and so we want to, really let the public to, have the awareness, to raise the awareness that, hey, these are the 2 major things that we generalize. We try to incorporate, all sorts of different attacks that we present in different areas, in different venues. Like for instance, we have this cross-app OAuth account takeover that we present in Usenix 25, Usenix 25, and then there are all other attacks, 20, Black Hat 25, Black Hat 24, 25. We try to, wrap them up and then try to reorganize them, generalize them, and to even including the RFC 9700, the old mix-up attacks, try to, generalize them in 2 different big buckets, which is, the new name code, where, we call it cross-2 OAuth account takeover, And then, the other bucket is cross-user OAuth session fixation attack. So this, if you have a chance to look at our latest draft that, with the link included on the first or second slide, you will see that, they are now being put into the section 2.2 and section 2.3. So of all these attacks, they are, have a lot of implications, as in, we find these different variant of attacks, in basically 20 plus platforms. All big names include, Microsoft, Google, Alexa, OpenAI, for the first category of attack. And then for the second category, cross-user OAuth observation, we found 35 vulnerable vendors, again, all big names. Okay, so, and then this is making this a little more pressing that, than we wish. We've been reporting, so many problems, almost like day after day, with Kai-Shun's, doing all the, do that responsible disclosure. So prevalent across the industry as we spoke, and then, in terms of severity, like taking an example of one of these vulnerable platform, basically is talking about the Microsoft Power Automate. The worst case is that, I send you a link, you click it, then I can basically have any of your integrations integrated with my account. You don't need to really have you don't even need to be a user of the so-called Microsoft Power Automate platform. But let's say you as a victim, if you are owning the Microsoft Azure infrastructure, basically I can own your entire Microsoft Azure system infrastructure, where, with just a link, I can know what secrets in your Microsoft Azure key vault, and then I can pull your database and I can delete it, I can do all the crazy shit. So obviously, we have this whatever CVSS score, almost topping it, and then this made Microsoft, the system, re-architecting the whole stuff, to accommodate, these new attacks that we report to them. We have meetings with them, to help them understand the problems. So we have a lot of experience dealing with, different vendors, how to report the problems, how to help them understand, to even give them the best fix for them in their different settings. At the end of the day, when we reflect, we believe that, there is partially attributed to the lack of clear standards / security best practices. And this is why we think we want to have this new attack, what should be done, what is the right way of securing the system. Also, together with this urgency about, there are new systems being built every day because of this agentic AI hype. And so we think, we should take this chance, to seriously do something for the community. Okay, so talking about the code. This graph is a little too overloaded, but let me try my best to give you a good idea about how to launch a code attack. Okay, so first of all, think about if you are an user, you click a vulnerable, click a especially malicious link. So you start, that link is basically just look very much like how an OAuth authorization URL link and that appears in the OAuth standard. So you go to maybe malicious.com / this number one. You click a link. It will go to malicious.com / authorize client ID, redirect URI equals something, and then state equals something. This URL is generated by sort of this platform, the service that you interact with. Number one, and then they generate this URL in such a way that it's based on the auth provider that the tool gives, because in the auth provider, the tool gives, the tool says that I want to use this whatever authorization server, endpoint, client ID, and client credential. So the platform generates such a URL with, the randomness, in the state, and then which is binary to, the session. Everything looks right. Okay. So as we move on to the second step, so once your browser hit this, malicious authorization server, which basically does nothing about authorization, all it wants to do is to steal the authorization from another tool. So the way that we launch this attack is when you hit this malicious tool server, on the third column, right one, you see an evil logo over there. What it does is it will try to redirect to another authorized URL. Okay, that authorized URL is basically just captured from, what you see when you as a user, you want to, in this platform, you want to authorize an external tool. Just copy that URL, authorization URL that appears for another tool. Copy that, swap out the state with a freshly generated one that you receive from your URL. Swap out the state, make sure that you got a fresh state, not something expired, and then just redirect there. Now you will hit the fourth column, which is the authorized endpoint of the legitimate authorization server. Okay, the authorization server will think that, oh, this URL looks perfectly right. Okay, you copied it from a legitimate URL. All the redirect URI looks just so good. Everything is whitelisted. It basically couldn't tell there are any mistakes that is possibly that it can cache. So what it does is, and then I realized that, this client ID and this user potentially have an prior approval in the browser. It might just think that, the user has previously approved it, integrating such a tool, like in this case, Spotify with the Alexa platform. So I'm not going to even ask the user to reconsent again. So all the user see is just maybe a blank screen, just pure redirect, boom, 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 and then finally it will hit back the redirection endpoint of the platform backend. Like it could be alexa.com/callback, something like that. So once you hit that, that server will, authorization server, the callback endpoint and the redirection endpoint will just check, I know that, the user has started with hitting that URL with the integration with a malicious tool. Just imagine the user got sent this link that they try to click, or maybe the user just happened to, I want to interact with this malicious tool, or maybe they didn't even realize it's malicious in the first place. So the server will check, okay, this is a malicious tool. Now I get the auth code. The auth code looks just, it's basically just a code that the platform cannot tell what could be it, just a string, an opaque string to the platform. And then, this state perfectly matches with the one that I use on step one. It is issued by me, and then it tied to my session. Everything looks so correct. And now I got a code. With this code at the relation endpoint node, the next thing that it's going to do is to make the access token request. Now we're talking about the last arrow. It will make an access token request back to, the token endpoint according to the auth provider of this malicious tool, which is malicious.com/token endpoint. And from there, this code that we basically got from a legitimate authorization server, from the legitimate tool, eventually will be sent to the malicious tool's token endpoint. And from there, once you got the code, you basically can own the account of this user. What you are going to do as an attacker, you will launch this authorization code injection attack. So As a user, you go to your own Alexa account, sign into Alexa account, and then you say, okay, now I want to have an integration or have a account linking with this Spotify account, and you launch an authorization code injection to yourself. So you swap out the code with the one that you just steal. Eventually, without even knowing the legitimate client ID and client secret, this account linking will be binding the attacker's platform account, Alexa account in this case, with the victim's Spotify account. Okay. So with these all attack steps, this is basically I steal the account linking, try to bind victim's account. On the bottom second row, the attacker's account from the platform, see Alexa side, attacker's account got bind to a victim's Spotify account. And then, this is basically as worse as account takeover. And think about, in the smart home case, or in those IoT control platform, if I can bind your thermostat to my smart home account, I can obviously do everything on your smart thermostat. Or if it's a garage door, if it's and all others, whatever crazy IoT devices that you can think of, basically you can just own people's smart home devices. Okay. So this is what we call code. And with this very worst consequence, we further expand, how that thing will be used or how that would be exploited in this OAuth as a service context. So think about we have this arcade and composio, different OAuth as a service contexts. There are even more crazier attack where this platform, if you see number one, they are pre-building some off-the-shelf tool with even the OAuth providers fully completed, meaning that this company, they are saying they're selling that okay, if you want an access token from a Google Calendar integration, I'm gonna supply my client ID, Arcade's client ID, client secret, and then they will use Google/auth endpoint, Google/token endpoint. They fill all that all provider fully completed with their own client ID and client secret, and they're going to share this tool with whoever their customer, the tenant who sign up an account to Arcade. And then, they made use that, okay, this is so worryless. If you want to, have a whatever API or whatever tool that try to integrate with Google Calendar, all you need to just, have this mapped it, use my off-the-shelf tool, and then you write your own API, and then you write your own code. It's just an access token for you. And in that case, we observe this in this real-world system. We have this Arcade, platform, and then two more vendors that we figure that is so vulnerable because there is this all provider and tool, mix up or, sharing. And then there is another second class of problem that we observe in this OAuth as a service context, which is, okay, the second one is more like code. And then in our previous presentation in Black Hat 25, we call them cross-agent code, which is that, the tenant isolation, and those, when we talk to those engineers, from these, vulnerable companies, they didn't even realize that is a thing. They thought that, I have some sort of tenant isolation and make sure that, a tool can only access the auth provider built by the same owner. What the problem could it be? And they didn't realize that, with this cross-agent code, think about, you have one tenant, and it has its own auth provider, it has its own auth tools, it has its own tools. Then you have another tenant, which is, a malicious guy, who are able to offer his own tool and his own custom auth provider. This is talking about how this malicious tenant using this opportunity of incorporating an auth provider, putting in malicious auth token endpoint to attack cross tenant. How I can get eventually some access token from a tool of a particular tenant, and then we incorporate how all these new attacks everything under this umbrella code. So we cover everything in this code umbrella, and then we made this attempt, and then we draft a new version, which is session 2.2 in the draft documents that we share with everyone. Now, in order to make a defense, the high level idea is that we want to ensure that the tool that starts OAuth, which is at the auth endpoint, we know, okay, the system should know that, okay, this is the tool that starts OAuth, for the linking purpose. And at the point where, at the redirection endpoint where we got an authorization response, we got a code, at that moment of time, we have to also ensure that this is the same tool that is responding or receiving, that is supposed to receive an auth code at this moment of time. If this enforcement is wrong, or if we figure that there is something misaligned, mismatched, we should abort this connection. So we basically talk to just so many companies. We arrive this conclusion that this tool is a natural boundary. Also because this is how the boundary of how every system, how every engineers would think that because tool basically represent an owner. Okay, each owner has different tools, and with the tool concept, it is a natural boundary between a natural boundary to isolate. Okay, there are no cross tool attacks. Okay, a tool from one engineer, a tool from one developer should not influence, a tool from another developer. So, tool is a basic thing that we think has to be used, and then it has to be also encoded in the redirect URI. So the redirect URI could not be just only alexa.com. The redirect URI should be alexa.com/toolid. And in some cases, as we detailed in the draft, it has to even incorporate more things into defining what this unique ID should be. We call this unique connection context ID in the draft. Like, let's say in the case of, you have even this OAuth as a service concept, then maybe you have to even incorporate the tenant ID as part of this context in the redirect URI. So it could be something like tenant-to.alexa.com. Okay. So we written down, this defense, and then not only that you have to change the redirect URI, also at the redirection endpoint, you have to make sure that, okay, from my section, I knew that, it starts with 2.1, and then from the URL in the redirection URI, we see that 2.2 is being put in as part of the redirect URI. I have to basically match 2.1 equals 2.2, or it's wrong, then I abort the connection. Only if they are matching, we'll proceed. Okay, so I've talked a lot about this code attack, and I now want to pass the mic to or maybe before I pass the mic to Kai-Hsun to cover the other section, which is related to this cross-user OAuth session fixation attack. I want to ask if anyone wants to talk about code first, or we want to move it all the way to the last page. Anyone?
Any questions from anyone?
Or you will have to wait until the last.
It's good. We can continue and then have the questions at the end. That's good as well.
Okay, cool.
But thanks for the introduction. Very good.
Hi, everyone. Thanks, Adonis, for covering the first section. And let me continue with the rest of the slides. Yeah, I think I now have the slides control. So I'm going to talk about like the second category of attack, which we call cross-user OAuth session fixation. So at high level, it's also based on this OAuth connection concept, but it's like we're exploiting some different stuff here. So just imagine like a traditional OAuth deployment for web applications. It's usually like deployed in a single domain in a same single user agent. It's single domain or single origin because like the place where the platform or application that maintains its user session, it's the same origin that the OAuth client is deployed, is hosted. So and it's also the OAuth flow is all done in the same user agent, the web browser. So in this case, at the redirection endpoint, the user session can actually be consumed by the redirection endpoint to identify which platform user it is, or which platform user that should where the X token should be bound to. But in certain scenario, like this user agent session may not be always available. For example, if you are building like a cross-origin web application, then probably say your user session appears in Alexa.com, but your like redirection endpoint is deployed in Amazon.com. So in this case, on the left-hand side, you can see that like when the OAuth flow comes to this redirection endpoint part, then there's no platform session to consume, right? And so that's a big trouble. And on the right-hand side, we are seeing like in the native apps use case, the native app could be crossing user agents in OAuth flow. So here I'm not talking about this RFC 8252, which is talking about like the native app that's being act as a public client. Here, let's say Alexa, it has a backend that wishes to consume the tokens and also act as the confidential client to conduct the OAuth flows. So like at the Alexa's platform backend, its redirection endpoint must somehow identify who the platform user is so that the access token can be linked to that platform user. But if what the Alexa could do is just simply like following RFC 8252, the established OAuth standard, then you are like running OAuth, you are like punching out to the external user agent, which is a web browser, to do OAuth, which may not have an Alexa user session in the browser. So in this case, at the redirection endpoint, you also don't know, well, which platform user should the token be bound to. So if you look at the right-hand side, it's a little bit similar to this BFF backend for front-end architecture that's discussed in some of those advanced OAuth spec, like OAuth for browser-based apps, or even OAuth 2.1. But here the difference is that like this backend is a general purpose native apps backend, plus like the received tokens is not just like stored in the BFF. It shall be linked to the user session at the platform, or user identity at the platform. So we feel like what's lacking here in the OAuth standards or in the security best practice is that first, there is not a normative way to actually conduct OAuth in this cross-origin or cross-user agent complex deployments. And because of that, the security considerations are not fully like explored. For example, we've seen in almost all of spec that there is a section about CSRF, right? CSRF is basically if the state is not there, or if the state parameter is not tied to the user agent, then you could like inject your an attacker's token or attacker's authorization code to a victim. But the opposite side of it, the session fixation part, is not widely discussed, which is like, what if like the attacker could start initiating overflow and then let the victim complete it, and then eventually the token gets linked to the attacker. So this creates a gap. But before we talk about what kind of attack we could launch based on this complex scenarios, let's first discuss how these platforms usually design their account linking system. So we see that there is a gap between the session in cross-origin or cross-user agent use cases. And to bridge this gap, the platforms would usually invent the so-called authorization session or OAuth session, this concept that would be used to track the user session between different origins and user agents. In particular, it is a session, the authorization session or OAuth session is something that's derived from the platform user session, but it would be passed across the origin user agents, and then for the platform origin B here, or like the redirection endpoint to consume. So in this way, the OAuth client can therefore determine like the user that the access token should be linked to. And we see two common designs here. One of the designs is that some platforms would just embed this OAuth session or authorization session in a separate URL parameter. So basically, they are trying to like modify the OAuth flow to invent an extra request to the the origin where the redirection endpoint resides. So usually you would start OAuth. There's this first request to the platform origin A, where the platform session would be attached. But here the platform would like return, instead of directly returning to the redirection endpoint, sorry, not redirection, but the authorization endpoint, authorization request URL, it would simply like first generate this pre-authorized request, which contain this authorization session. And then this authorization session would be set in the browser in the origin B, which contains, which is the endpoint where which is the origin that the redirection endpoint is deployed. So in this way, the authorization session could be tracked, and at the redirection endpoint, it knows which platform user actually starts OAuth. Okay, so the other similar design is that it would reuse the state parameter in OAuth, because anyway, like the state is designed to maintain application state during the OAuth flow. So it would embed a sort of session ID or maybe a full authorization session into the state parameter, and then let the state carry along the OAuth flow, even across origins or user agents. And then at the redirection endpoint, it could extract from the state to know which platform user it is. All right, so these are the two common flaw design that will both result in the session fixation attack. So the attack is actually quite simple. As I've mentioned earlier, it's just like the attacker starts OAuth, get a sort of OAuth URL. It could be just the authorization request URL, or maybe it could be a request that preceding that request URL. So we call it a pre-authorization URL. But the same thing in these two designs is that there is an authorization session embedded in that URL parameter. So by sending a link to the victim would go through the OAuth dance, and then at the redirection endpoint, hand in the authorization code in the state parameter. And at this point, the redirection endpoint would see that the OAuth flow to be initiated by the attacker. So it would bind the received access token to the attacker. So that's how it works. And the consequence is that the attacker gains control to the victim's resources. It leads to account takeover of the victim's tool. And also here, similar to the code attack, if the victim already has authorized before, probably if prompt equals null is configured, then there's no second consent needed. So it's a pretty stealthy attack, I would say, because the only user interaction needed is a single click on this initial OAuth URL. Okay, so you may wonder here, like, would Pixie solve this problem, right? Well, actually, no, because Pixie only binds authorization request to access token request. But here, as we can see, in the attacks case, the authorization request and the access token request are completed by the same user in the same OAuth session. So here, the flaw actually resides in the point where the OAuth is initiated and like the person who actually conducts OAuth. So the defense is also based on this same idea, we enforce that the user whoever starts OAuth should be the same user that completes OAuth. And usually this defense requires a mapping or like a binding, a validation of the binding between the existing user session and the authorization session that's like derived from the user session. But here again, we face this like nightmare that like the OAuth is not a simple single origin or single user agent deployment. So usually it requires the OAuth client to instruct the web browser to redirect back to the original user agent or original origin where the OAuth is started. So in this way, the user session, the platform user session is available, and it's ready for the OAuth client or the platform backend to match this session integrity. So depending on the different deployment scenarios, say whether it's putting this session in state or inventing a new session, or if it's cross-origin, cross-state, or cross-origin or cross-user agent, there could be different defense, a little bit like variant defense, but the high-level idea is the same, which is this enforcing this user identity matching. Okay, so of course, say for like on the right-hand side, for the cross user agent case, there might be a bit one variant defense, like if you're only trying to ensure that it's the same user, then probably you just let the user re-authenticate himself in the new external user agent, which is the web browser, so that like you could identify that it's consistently the same user. But this defense, it does work, but one downside of it is that it requires the user to like relog in, right? Relog in at the platform. So it may affect the user experience or usability. So we still recommend like the defense in the right-hand side of the slides, which is like, yeah, like basically you cannot just deliver the code in the external user agent, which does not have a platform session. You need to redirect back to the original user agent, the Alexa mobile app, which has the platform session, so that the platform backend can do the like validate the matching. Okay, so and yeah, back to our discovery so far, we found more than 35 vulnerable vendors, including 7 workflow automation platforms, 5 voice assistants or smart homes, 3 AI assistants, even including 2 MCP clients, 16 native apps just only wish to implement some simple logic like doing calendar synchronization or file import, but they don't have this spec for doing it all securely as a confidential client. And we also witnessed that it's like besides this cross-origin or cross-user agent deployment, even on same origin and same user agent deployment, so it's like the basic OAuth since 2012, we are also witnessing this session fixation attack. So it means that like it's not only about like that there are several use cases where the spec does not cover, that people are prone to make mistakes. It's also like we don't actually highlight this session fixation as an attack vector. So people may see it like, yeah, I just embed this user authorization session in a state parameter. I'm using the state, right? So I don't have this CSRF issue. So I'm fine. My system is secure. But that's a wrong belief. And in particular, similar to code, I want to discuss this session fixation variant in OAuth as a service context. Because for these platforms, for these service providers, we see this problem as a like inherent issue, an issue that's there in their architecture by design. Why is it the case? Because like it's not just about cross-origin or cross-user agent. It's about like the separate responsibilities of OAuth deployments. So like the OAuth client and the client application used to be one entity, right? But now in these kind of new new deployments, we are seeing that the OAuth as a service, it acts as the OAuth client. And then it handles all of the OAuth responsibilities. And then on the other side, the agent or like a tenant could build its own applications. So we are seeing this inherent separation of duties. But who should like verify the state? Who should verify the user session integrity, right? The agent built by this OAuth as a service tenant, it has access to the user session. It can know which user started the OAuth. It also is responsible. It should be responsible to match who ends the who completes OAuth, but it does not handle OAuth responsibilities. It's outsourced to this OAuth as a service provider. So this kind of deployment or trust, or you could say its responsibility issue, is also why it and this attacks can happen. So yeah, so back to this like IETF draft, we wrote down what we believe are important for these kind of scenarios. But we also this is a call to action to the community that probably we also need a new spec, right? For OAuth, like OAuth 2.0 for native app backend, right? So previously we only have OAuth 2.0 for native app, which is a public client. Native app itself is a public client, but we might need a new spec to tackle this scenario where the native app is just like a user agent. You can think of it like a browser, right? It has, it can like send and receive requests and responses from a backend. It can store sessions. It can manage sessions. But it's the native app. It's not meant to store tokens. So we might need this as a new auth spec so that we could, or like developers could like implement these OAuth patterns for native apps securely. So in particular, like the OAuth pattern on the top right of this page should not be suggested, right? Because this is intrinsically vulnerable to session fixation. Instead, we need a secure pattern, which is like the authorization code and state should be handed in, not directly in this external user agent, but it should be returned to the OAuth client, first returning back to the client app, back to the native app, and then returning to the OAuth client at backend by the native app itself, because it is where the session exists. So I think that's pretty much I want to cover for this session fixation issue. And I think now I'm going to hand it over back to Adonis for the for a summary.
All right, so this is basically our very final last slide. I hope that we made the point that in terms of the urgency, in terms of what the problem is, and the motivation and justification of making this into a working group draft, to help us help the industry, these engineers. They shouldn't just be doing new system, making the whole world really very vulnerable. If we think about, if you remember, we talk about, there were 40+ systems. If one system is wrong, all its integration must be wrong. If thinking about, for instance, Google Home was found vulnerable, it doesn't matter, how each individual OAuth integration, whether or not this provider, vendor, or maybe we call this IoT provider, second IoT provider, whether or not they fix their OAuth perfectly. When the platform is vulnerable, all this, there is a platform-wide issue. So basically, it's almost like just name maybe just a Dropbox, for instance. Perhaps if in one platform is vulnerable, an attacker can basically take over your Dropbox account. Okay, even if Dropbox make perfectly their own responsibility, with their own responsibility, even they make their own OAuth server AS, perfectly secure. With a vulnerable platform, this account takeover can happen. And so we see the needs, and then we also, have a good understanding how things should work. We ourselves, has architected one such platform. We secured it way years ago. And we also have accumulated so many experiences in terms of how do we responsibly disclose these problems to different vendors. For some, maybe more critical vendors, so we even have meetings with them. And now, we are bringing everything together, and then we rewrite this draft with all the latest findings, hottest findings that people want to know. We try to make a good balance between these OAuth terminologies, client, AS, and then also the engineer expectation. We hope that this draft is written in a way that the engineers can easily consume, digest, and then make the responsible fixes by themselves. And the outcome is this URL. So we hope that you can spend some time looking at it, and then hopefully give us some useful feedbacks and comments. But simultaneously, I would like to open the floor, to discuss how would you guys think to move this into a more official status, instead of just having us doing maybe 10 more disclosures, 100 more disclosures. I think we should have a good document that we can point to when we talk to different people, or when these engineers just come to this OAuth draft to look at, what is the latest best security best practice that they can work with. All right, thank you.
Thanks to both of you for the presentation. Are there any questions on the presentations today? I suspect that people need to read up on some of the papers that you have shared and included in the presentation, and to think this through and respond. We had a presentation at the last IETF meeting. Was it the last one? I think you had it in your history slide, so that was well received. Or was it the meeting before? So clearly good work. Any comments? So the normal process is sort of like you have the individual submission, and then we would do a working group adoption call, which, like today, we have only a couple of participants, but this would be then distributed across on a mailing list across the whole working group, so more people have to then have a chance to actually provide feedback. We would have to do that anyway, because that's the procedures. Even if we decide something during the meeting, we'll have to confirm that on the mailing list, and and then we would have to take it from there. Any quick reaction? Peter, Aaron, Philip.
Someone raised hands, right?
Yeah, that's me. That's me.
Oh,
So just to ask possibly some
children voice. That was not you, I can tell that.
No. Those days are long gone. I think that was Philip.
Okay.
So my question is, do you have not to the authors necessarily, but more to Hannes perhaps? So the BCP has only recently been finished, only because it took like 400 years to do. And so now we're gonna update it, and that's lovely. Do you think an update to that is in order? I don't think you want to BIS it, right? You don't want to obsolete the current. Do you want to sort of pile these things into the BCP?
Yeah, no, we didn't. So that's a good. Those are all good questions. So we didn't want to obsolete the current document because it's actually still valid. But what we back then decided, like we said, that now we really need to finish the document, the BCP. At least that's what the working group wanted, and then to start new work on this document. Of course, back then when we made that decision, it didn't look that severe, to be honest. So of course, many of the things are happened very recently. Some of the developments on these AI agent communication and authorization of those agents is very recent activity. So so that's obviously something we didn't anticipate. So yeah,
yeah, from
so I
my
think you're
perspective,
always going to be. No, if I may, I think you're always going to be in the situation where there will be another problem down the road, and so you have to pick a point in time where you decide to cut it and publish, so that you have at least that part of it in the works. If you wait too long between these things, then they're obsolete before you start, and that's not good either.
Correct. Yeah. Aaron.
Yeah, thanks for the presentation. I remember looking through this a few months ago with you. It seems like these are pretty specific recommendations for like particular attacks. Maybe one way to handle it is to not call it a general OAuth security update, but more targeted towards the specific like account linking. I don't know what the right name is, but like find a name that is more narrow in scope. My main worry is I don't want people to think that the current 9700 is not relevant anymore. Like that's definitely still intended to be, capturing the best practices for most OAuth use cases, and this is like a more narrow application of it that is important to call out. But I don't want it to look like it's replacing the other one.
I do agree that, I think it at most supersedes session 4.4 in 9700. And the cross-user session fixation is more like a new section. I don't think we intend to replace the whole thing. It's more like, if we have a chance, if it's just completely ideal, hopefully, 4.4 should be swapped with, our session 2.2. And then we insert, this 2.3 into the RFC 9700, and everything else is still very relevant. That, we definitely concur. But
Yeah.
maybe I think this is. I think we need some.
Add that, like that section 4.4 of 9700 is the mix-up attack section. That's
Yes.
the published mix-up attack section for security BCP. Yep.
Okay, so we would like to, get some, concrete directions as to how we should move on. We are okay, or maybe we are really open to, like even Aaron's idea about, having perhaps a separate document to just talk about this account linking stuff. But I mean, when may I ask, how we should know, or, is there anything we missed in order to get a final decision?
No, you didn't miss anything. So like the approach is like presented like you did, and then there are some. One thing is to for us, Rifat and myself, to make a call for adoption on the mailing list, which is like, does the group want to work on the document? A secondary question is, which we can decide later, which we are just discussing now, is like how would we shape the document in context of the security BCP that was published earlier? While that's interesting and of course important, but it's probably a secondary issue. I think it would be the most important aspect is for people to digest your presentation and also look at the material that you reference, because there's a lot of certainly complexity in the work and a lot of new stuff that happened, very good work, and then to make a preference and express support for the adoption of the work. That's the first step. But I'm Brian, I have you on the queue as well.
Deb just touched on this, but a BCP can reference multiple RFCs, right? And it seems to me like the right, at least way to think about moving forward with this is completely new content, new security considerations. Even the mix-up doesn't sound like an update so much as a new variant of, or even variant's probably even wrong, or a new manifestation of something mix-up like. So I imagine it preceding something. Deb, please correct me if I'm wrong if it can't work this way, but it would be like, new security considerations around OAuth 2 and such deployments, or, a better title than that, but something that lists these things and then would ultimately, if it makes it through the gauntlet of various things, would end up as another security considerations document under the mantle of whatever the BCP is that points to 9700.
I believe you can do that. I've only been doing this job for 18 months. I should know, right? Not an expert here, but I believe it's possible to just sort of stack these things underneath the BCP. That way you can reference the BCP, and then whatever's under the BCP at the time is what you get. And I would think for security recommendations that would be the way to go, because you're always going to find the next new attack, the next new thing, the next new whatever. And so if you can't wait till all the attacks are found, or you'll never publish anything. So I do think publish early and publish often when it comes to stuff like this. Your focus, of course, in the draft will be what somebody can do to mitigate, right? It's not so much about the attack, which you already have documented in your papers, but what the mitigations are that an implementer can use.
I don't think this necessarily applies to the work you will be doing, but I would caution against labeling every single new piece of work that happens to touch fixing or improving a situation that's related to an implementer doing something wrong or new, and labeling it as a security vulnerability or security fix, and then stuffing it under the BCP. The BCP should just have security recommendations. I don't think. I think if the resulting document is mostly new work, documenting new patterns for deployments that they should follow for, this particular use case, I don't think that applies to be stuffed under the BCP. If all it does is in one of the sections that it updates the existing 9700.
Thanks, Philip. Yeah, lots of good suggestions. What I didn't hear anyone say like that this is work that we shouldn't work on. Obviously, we just heard about an attack, and we better do something about an attack and do this. The discussions we have on how do we best frame this in terms of the documents, which I think is good, but it gives me the indication, which obviously we'll double check with Refat and Deb, is starting an adoption call, and then also double checking on what's actually possible in terms of how to reference different things, different documents. I'm not quite sure myself either what the full list of options are. And when we do the adoption call, we'll also ask for feedback, because on whether anyone has an opinion about what precisely to do document management wise, because then people will have read the document, the latest version, which was just published today, if I'm not mistaken, and we'll also look at the reference material, so we'll have a much better understanding. So I think that will give us some additional insight.
Sure. Okay. So I myself have a question. Do we have, at least among the participants here, a consensus that this problem, regardless of whether it should appear in a new BCP or a new document, those are more like paperwork. do we believe that, based on, what you heard, do you believe that this is sufficient to be considered as an adoption to something that worth the attention of the working group? It should appear somewhere.
Well, that's the sort of the working group is much larger, so we'll need to get far more feedback from the list. But Rifat and I will consider sort of issuing an adoption call during the next few days on a mailing list, and then we get the full response. And it also we give a time window for providing a feedback, which gives people the chance to read the document carefully and so on. But as I said, like I think it was like you nicely illustrated the importance and the severity of the issues. So yeah, sort of, I think came across. Anyone, and I don't think, or does anyone disagree? Just double checking. People left already. Yeah, okay. Yeah. Cool. So thanks again for the presentation. It was really good. And I think you sent the slides to Rifat already, so he can upload them to the tool. So we have them. Is that true?
I think so.
Okay, cool.
All right, thank you. Thanks for everyone.
Yeah. So we'll take the next steps.
Yeah, keep us updated. Keep us updated about the progress, and then how we should help in terms of moving this forward. All right, thank you.
Yeah, definitely. Rifat and I will have a conversation with you separately. We always do that with new participants anyway. So. Yeah.
Okay, so my one last thing, just personal opinion or personal stand. I don't necessarily have to be as one of the authors of this new document. I'm perfectly fine dropping my name. If dropping my name can help, move this faster, I myself.
No, we are always happy to have new people in the group. It's always good to get different perspectives and different expertise. So really appreciate your time and effort into all of this. Yeah. So I think it's definitely a plus that you guys helped to work on this, came to us, came to the working group, and presented this. Really appreciate it.
All right. Okay, cool. Thanks a lot. Thanks for the time.
Thank you.
Thank you.
Thank you. See ya.